At another example, let's answer some questions from a histogram that's been created for us. Here's some, again, real data from 195 nations recognized in the United Nations. This is from 2008, and what we're looking at is the life expectancy. The life expectancy of citizens from those countries. And so you can see, again, the distribution, if we want to talk about that. What are all the possible values? And so it looks like some countries go down all the way to 55 up to 85. And then how often do those values occur? And so you can see those numbers along the top. So how many nations were represented in the histogram? And again, there's 195 nations in the United Nations. This one represents almost all of them, 182, right? But you by adding up each of those heights of the bars. How many nations had a life expectancy of at least 70? At least 70 means 70 is the lowest amount. So this, you can see we're at 39, 49, and 35 there to get you 123. How many between 65 and 80? And so this one you have to look from here to here. And so you're adding those three values, 29, 39, 49. Gets you 117. And then what percentage of nations had a life expectancy less than 80? And so here's your 80, and you're not going to count the 35. You're only going to count everything less than 80. And then you divide that by 182. You get a relative frequency, 0.808, which turns into 80.8% of the countries, right? But interesting, again, just how amazing just looking at the data. Remember, in statistics, the data all means something. It's not just numbers. We're not just calculating it. Interesting to see, depending on what country you live in, your life expectancy is a lot lower. I think the United States somewhere in the high 70s for us. But you can see that if you live in certain countries, you're not living up to even 60. Let's continue now. We talked about distribution, what it is, right? How often some values come up and what are the values possible for the variable. This is an essential piece here, and you can see partially some of the graphs here. But when we describe the distribution or its shape, remember SoCS, shape, center, and spread. The first thing we want to look at is its shape. These are all the different shapes distribution can take, or data values, and each shape tells its own story. Okay, and so you can see you have uniform, symmetric. You can see the data of a histogram being skewed left, skewed right. You can also say negative skewed or positive skewed. And it depends upon what we call the tails, right? The tails are the end of these curves here. And so you can see skewed left, just I see a tail on the left side. Skewed right, I see a tail on the right side. Symmetric, you can see both tails there. And then you have what's called unimodal, meaning that you have one really high point versus bimodal, like two very high points, right? And again, remember the mode means the most. And so that's where we have that term modal. Some other interesting things that can happen. Let me zoom in on this here. That you could have gaps sometimes in the data. And if that happens, that means maybe that your data you collected has two different populations potentially. Or in this case, you have outliers. This is also potentially telling a story. Maybe something's up, something's different. What would the difference be? And again, these gaps here looks like bimodal also. And again, you can have a kind of a combination of these, or not everything's perfectly these things, but you want to have an eye, start developing an eye for the shapes of those. Example 3 is like a test problem we do in class many times working together. Go ahead and try those in the next video. We could look at some of the answers to those questions there. But given a context, what would the distribution be? Think about what are the possible values for this variable, and then how often would they occur?